Hello everybody, welcome back. In the previous video we had discussed about linked list, its types, operations performed on single linked list, and also we learned the coding for insertion and deletion from front end or from the beginning. Today in this video we are going to learn the variations of insertion in the single linked list. That means in how many ways we can insert a new node into the linked list. So let's move on to the topic. So these are the variations of insertion in the single linked list. Consider this is your linked list with head and the last node pointing to null. So I can insert a new node at the beginning, that is at this position. I can insert a new node, or at the end here in this position, or insert before a given element. Suppose say if my key element is 34, I can insert a new node here. This is also possible in linked list. And inserting after the given element. Suppose say again this is my key element, I can insert, so my new element will be inserted after this key element in this position. So these are the variations of insertion in the single linked list. So now let's move on to the coding of insertion at the ending. So in the previous video we had learned how can we insert in the beginning. So here let us know how to insert a new node into the linked list from rear end or at the ending. So here you can see struct node. So why we are making use of this part is a node contains two parts, that is information part which is of integer type, and the next part which is of pointer type, that is going to hold the address. So these became two different data types, so that is why we are making use of structure here. And the very first node or the starting node will be pointing to null, so that is why. And also the start node is going to hold the address. We are making use of struct node start to represent or to indicate that it is of pointer type. So initially it will also be null. So coming to the coding part for the insertion from rearing end. So my function name is void insert rear. So I make the function, or this function is having one parameters, that is element. So that element is going to be the information part of the newly created node. Next is struct node star rear. So I'm making use of one more variable called rear to represent the rear node, or to represent the new node which is to be attached to the rear part of the linked list. So this rear pointer will be holding the address of the newly created node, that is new struct node. So this new keyword will be going to create a new node of structure type. So the structure type will be having what? Information field and the next field, that is integer part and the pointer part. So that is why we are making use of the type struct. So this struct node star rear is going to hold this rear pointer is going to hold the address of the newly created node. Then I need to fill the newly created node's info part with my element. So who is pointing to the new node? Rear. So that is why I am making use of the statement rear of info is equal to element. Then rear of next will be null. Why? Because whatever the element or whatever the new node you are going to create, it will be placed before the existing element. That is, suppose consider you already having an address, having a node with value 10. So if you are going to create one more node with the value 20, so that node will be placed before 10. So that is why, and this node with element 20 will become the last node. So the last node links field should point to null, and therefore rear of next equal to null. Now I need to check the condition. If start equals null, suppose consider you do not have any nodes, your linked list is empty now, and obviously start will be null. So if that is the condition, what should happen? Start equal to rear. So start will be pointing to null, and a new node is created now. Still still start should not be null. So therefore it need to be filled with the address of the first element. So who is having the address of the first element or the newly created element? That is node. So that is rare. So start equal to rare. Else, if this is not the condition, else if start is not equal to null, then what should happen? I'm creating a new memory location called temp that will be pointing to start. Then while, so I need to traverse now. While temp of next not equal to null. So this loop will execute until temp of next becomes null. So when temp of next become temp starts traversing from the starting node, and it will traverse until it became null, until the next part of the node became null. So if this is true, so when temp of next part is not equal to null, then what should happen? Temp equal to temp of next. So temp will be moved one step forward, that is temp will be jumped to the next node. Then if the condition become false, so when temp of next becomes null, then what should happen? Temp of next should be equal to rare. So temp of next, that is the address field of this temp variable, will be filled with the address of the newly created node. So this is the condition for inserting from the rare end. So my function is over. So only this much. So this is the condition to insert new node to the rare end of the existing node. Then I will display this node, void display. So here for the display function, I am making use of the same temp pointer. I am making it as null. So now temp became null, that is 0. No value in temp now. Now I start traversing for temp equal to start and temp not equal to null. Then what should happen? It will come inside the loop. So after executing the inside statements or body statements, again temp should be incremented, no? So temp equal to temp of next. We should move the temp pointer to the next node. So if the condition is true, it will print the information part, that is value, temp of info, and then so this is my function to display. Then from the main function I start sending the values. So what is my function name to insert in the rare? That is insert rare, and I with one parameter. So insert rare with an element 10. So one element got inserted. Then insert rare with one more element, that is 20. And again insert rare with one more element 30. So this is my linked list now. So you can insert one more element to check. Insert rare of 40. So these many elements I inserted into the linked list. Now I want to see what are the elements and in what order they are displayed. So after inserting from rare, and I make use of a display statement. Display. So this is my function, or this is my program to insert a new node into the rear end of the linked list. So there are no errors in my program. Now I will show you the output. See, you can see here in what order I inserted the elements, in the same order the output I've got the output. So if it is front insertion, then 40 will be in the 40 will be in the top position. So this is rear insertion. So 10 became 10 is my first element, and 10 is only in the top or the very beginning element of the linked list. So this is the program for inserting from the rear end. Now let us move to the another part, or the next part of variation in inserting, that is inserting before the given element. So here you can see I already told you. So suppose say this is my element, or this is my key element. When my key element matches with the element in the linked list, then the node will be created before my key element. So this is the new node which got created before the key element. So now let's move on to the coding part of the insertion before the given element. So I will remove all this code. So for inserting before a given element, first I should have some elements in the linked list. So I am making use of front insertion here. Void, you can also make use of rear insertion if you want. Void insert front with one parameter. Then struct node star temp. Again temp variable to hold the address of the newly created node. That is, with the new keyword I am creating a node of type structure. Then the new node's info field should be filled with a value, that is element, and temp of next should be equal to start. So why temp of next should be equal to start? Suppose you can if you are viewing a linked list which is in which the nodes are inserted from the front end, the very first node you insert will be placed in the last. So the last node's link field should be null. So who is having null currently? It is start. So that is why temp of next equal to start. Then start equal to temp. So this block is for inserting from the front end. So when I call this function with 2 or 3 elements, so when I call this function with the first element, one element will be in the linked list. With the second element, 2 nodes will be there in the linked list, and with the third element, 3 nodes will be in the linked list. So it means that elements are existing in the linked list. So I inserted some elements using front insertion. Then I have to insert before a given element. No, so my function name will be insert before with int element and with a key element to compare with the traverse and compare in the linked list for my element. So insert before. So this is my function for insert before a given element. So what I'm doing is, now I'm creating a node, or I'm creating one more pointer, that is temp equal to new struct node. So as usual, when you call this function with a new element, new node should be get created, no? So that new node's address will be in temp, as you all know. Then struct node star previous. So I'm making use of another pointer here, previous, to point to the previous element or the previous node. So initially previous will be null. Then struct node star current. So I'm making use of current element that will be pointing to start. So using this current element, I start traversing now from the first element or from the first node. Start current should not be equal to null for this condition. Then what will happen? Then previous is initially null and previous will become current. Then current will move on to next. So why we are making use of this current pointer is, since we are not having the privilege for reverse traversing or backtracking in linked list, and if I want to insert a previous node, that is if I am pointing in one node and if I want to print the value of its previous node, then I cannot come back again. So I am making use of another pointer called previous, that is previous of next equal to previous equal to current and current equal to current of next. Then I will start for comparing with the existing value in the linked list to my key element, key 1. So if current of info equals key 1, then what should happen? So if the element in the linked list gets compared or gets matched with my key element, then temp of info will become element. So information part of the temp, so temp will be pointing to newly created node, so the new node's information part will be element. That is what I signed from the main function, or what element I need to insert. Then previous of next is equal to temp. So previous will be pointing somewhere before the current element, and that's next part will become temp, that is address of the new node. Then temp of next is equal to current. So if this condition become true, these operations should be happen. These operations should be performed on a node. If false, it will come out of the loop. Then I'll write a main function. Then I'll write a display function for displaying. Again, I make use of temp pointer. It will be initially null. Then I start traversing from the start, from the starting node. Temp equal to start, temp of next, just temp not equal to null. So this loop will run until temp becomes null. Then temp equal to temp of next. Temp should be moved one step forward. Then what should happen? It should display the information part, that is temp of info again. So this display function will be same for whatever the other functions you use to insert a node. So display function remains same. Only thing is that you need to code in such a way that this display function should work for all the functions. So that is the point. So I inserted some elements using front insertion. Then I made use of a function to check for the comparison of key element, and I'm displaying. Now in main function, from the main function I start sending values. Before that I will initialize the key element to search the element in the linked list. So it's I'm declaring a key element here. Now I will call this insertion front, because I need to have some elements, so that is why I will call this insert front 10, insert front of 20, insert front of 30. So say my linked list is having now 3 nodes. Then I will display this. these elements after inserting. I'll call the display function. Now I will give a key element and start traversing. So I will call the next function, that is insert before. So this is insert before of. So what are the two fields here? That is element and key element. So element is the one which I need to which I need to add newly and key is the one which I need to search in the existing linked list. So the element I need to add is 15 and my key element is, so before that I will give the value for key, that is enter the key element. So C in key. Now I will send the element and key element into that function. Then I'll again I need to know, after inserting a new element, how the linked list looks, how my list looks. So after inserting before the key element, again I'll call the display function. So irrespective of the functions, display function will work. It will work for all. Again I'll build this program for errors. So after inserting, my list is 30, 20, 10. Why? Because this is inserting from the front. I already said whatever the element you insert first, it will be in the last position. So that is why 30, 20, 10. And it is asking me for the key element to before that I need to insert. So I'll give the key element as 10. So here you can see after inserting before the key element, so my key element is 10. So where this 15 or where this new element got placed, before 10. So here you can see 30, 20, 15, 10. So my new element got inserted before the key element. So this is the program for inserting before the key element. Next is inserting after the given element. So consider this is my linked list. So if I need to insert after this element, see this is my element. Again I need to insert after this element means I need to search for this element first. Then if my conditions become true, then a new element will be inserted right after the key element or after my search element. So this is the inserting after the given element. So this is the method you need to follow. So now let's move on to the coding of inserting before the given element. Inserting after the given element. So again I'll remove all these. So I have created a node here and the starting node will be pointing to null. So again I need to make use of insert front. Why? Because I need to have some elements or some lists already in the I need to have some nodes already existing in the linked list to insert before the given element. So I'm making use of insert front function again, that is void insert front of with one parameter, insert front of int ele. Again a new node or a new temporary pointer to hold the address of the newly created node, which is of type structure. Then temp of info, that is new element, new nodes info part is my element, or element that whatever I give, and temp of next should be null, that is start is having null. Then again start equal to temp. So this is my function for inserting from the front. Next, inserting after. So I need to insert after a given element. So again I make use of int element. Element is the one which I need to insert after the given key element, and int key. So what is this key? This key is the key element is the already existing element in the linked list. So I need to compare this key element with the already existing element. Again struct node star temp new struct node. So after creating or after inserting 3 nodes into the linked list, again if I want to insert a new node, means obviously I have to create a new node. So that is why new struct node, new will create a new node. Then struct node star current equal to start. So current pointer will be pointing to the starting node of the linked list. Then I start traversing with this current pointer. For current equal to start and current not equal to null. So this loop will execute until current value becomes null. Then current should be moved one step forward. Current should be equal to current of next. Then what I will do, I need to compare my key element with the element in the linked list. So I'll make use of an if statement. If for condition becomes true, it will come to the if condition and check for the existing element is whether the already existing element is equal to the key element given by the user, that is key 1. If this condition becomes true, then what should happen? Temp of info, that is, so where the temp is pointing now, newly created node. So that will become that info part of that new node become the element, that is whatever the element you give. Next, temp of next. So new node's address field now, next field will be current of next. Then current will be moved to, then current of next will be temp. So this is the function for inserting before the key element. So in inserting after the key element, sorry. So in inserting before the key element, we made use of a previous pointer to point to the previous element, and current pointer to point to the current element. So here it is not so, we are not making use of any previous pointers here, just a pointer called current and temp is enough to point to the nodes. So next is my display function. Display function is same for whatever the functions you use. Again struct node start temp equal to null. So temp value is 0 now. Then I should traverse for start, for temp equal to start. Temp will start traversing from the first node, and temp not equal to null. Then temp equal to, temp should be moved one step forward, that is temp value should be incremented, or temp should move forward. So then what will happen? It will print the information part of the node. that is temp of info ended. Then comes the main function. So for in the main function I should call the insert front function first, because I need to have some elements before inserting a given element. So very first I will declare a key variable, then insert front of 10, insert front of 20, then insert front of 30. So these are the three elements in my linked list that are already existing. Then I need to display these elements. So after inserting, I'll call the display function. Then so the 10, 20, 30 are there in my linked list now. So if I want to insert after any of these elements, so I'll send the key value now. So enter the key element. Enter the key element. Then I'll read the value for key, and I call this function. So which is my function, insert after. So I call this function with a new element, say 15, and my key element. I call this function, and again I will display it. So here you can see, after inserting, the node linked list contains 30, 20 and 10. These are the three elements that the linked list containing now. So enter the key element. So if I enter a key element, the new node or new element will be placed after that key element. So say my key element is 20. So see here, 30, 20, and after 20 the new element 15 is placed. So this is how the inserting after the key element works. See, my key element is 20. The list contain here 30, 20 and 10. So after after this key element 20 and before 10, so after 20 means before 10, the new element has been inserted. So these are the variations of insertion in the linked list, and thank you for watching my video.